Satellites have revolutionized our view of the Earth we live on. In this photo, at the edge of the Earth, you can just see the faint outline of our atmosphere, only 100 kilometers or so thick, protecting us from harmful solar radiation and sustaining life. The Earth emits infrared radiation with a spectral signature close to that of a black body at a characteristic temperature. However, you will notice that there are large bites taken out of the emission by greenhouse gases, for example by carbon dioxide and water vapor. The emission spectrum is taken by a satellite looking down at the equator. In wavelength regions where these gases absorb, the emission never makes it to space. At wavelengths where CO2 and water vapor do not absorb, in the so-called atmospheric window, other greenhouse gases such as methane and ozone can have a disproportionate effect. These bites prove that the greenhouse gases are absorbing heat emitted by the Earth. Four examples of greenhouse gases are CO2, methane, nitrous oxide or laughing gas, and ozone. You might be surprised that ozone is a bent molecule. This is because it gives the lone pairs of electrons on the central O atoms as much room as possible. Each of these molecules has a number of vibrations which absorb at characteristic wavelengths in the infrared part of the spectrum. For methane, which has 5 atoms, there are 9 possible vibrations, most of which are able to absorb infrared light. And a molecule of methane is about 25 times more potent as a greenhouse gas compared with CO2. You've all been in a greenhouse. It's hot. The glass lets in visible light, which is absorbed by the plants and the soil, which re-emit in the infrared region of the spectrum, which is not transmitted by the glass, and so remains in the greenhouse warming it up. The atmosphere is like the glass, letting short-wave radiation from the sun in, but blocking some of the long-wave radiation escaping to space. The ice that forms the Antarctic and Greenland ice sheets provide a history of our atmosphere. Snow falling in these regions is gradually compressed to form ice, which becomes buried deeper as more and more ice forms above it. The Antarctic ice sheet is about 3,000 meters thick, and ice at the bottom of this fell as snow about 800,000 years ago. So ice at different depths gives us a ruler of time. The temperature of the atmosphere at a given time can be obtained by looking at the ratio of isotopes of oxygen and hydrogen in the water. Heavier water has a lower vapor pressure and so is more likely to have condensed to form the snow that fell. Small air bubbles trapped in the ice contain a preserved record of the composition of the longer-lived gases when the ice formed. Various analytical techniques, for example mass spectrometry, are able to make very precise measurements of the amount of various gases in the ice. 3 gases that have been quantified in ice cores are the greenhouse gases CO2, methane and nitrous oxide. The left-hand side of these graphs, which stretch back to 10,000 years ago, show data from analysis of ice cores, whereas the very steep rise on the right-hand side have come from more recent direct measurements in the atmosphere. The onset of the Industrial Revolution can be easily seen.